Good morning. Here, today's topic is superconductivity. This is a chapter from electric current, or better to say, current electricity. Okay. So here, these are the points to be discussed in this video lecture: definition, discovery, critical temperature, Misner effect, etc. Okay. So many points to be discussed here in this video. So, what we are talking about? We are talking about superconductivity. Superconductivity, it is a state of certain materials, not for all materials. Okay, not of all materials. It is a state of certain materials which can exhibit the property of superconductivity. What is the meaning of property of superconductivity? Means that those materials will be able to pass electricity through that material with zero electrical resistance. We know that whenever current flows through material, whether it is made of copper or aluminium or something else, so in those cases, what we find that it has some resistance, and due to the presence of resistance, there is some loss of energy during the flow of electricity through the wires or through something else. You have studied Ohm's law, so there you have got the concept of resistance. Okay, so that resistance can be minimized to zero by using certain technologies, such as lowering the temperature below the critical temperature. Lowering the temperature of the material below the critical temperature. Critical temperature is a temperature below which certain materials can exhibit the property of superconductivity. So what I have mentioned here, that superconductivity, this is a state of certain materials, okay, in which the materials are able to conduct electricity with zero electrical resistance below a critical temperature. So that is the definition of superconductivity. And keep in your mind that this property of superconductivity cannot be found for all the materials. Certain materials are there, and you have to maintain a temperature which is below the critical temperature, and this critical temperature is different for different materials, not same for all the materials. Okay, this critical temperature is different for different materials. So this was all about the definition of superconductivity, right? Now discovery, the point number 2 I have written here, it is discovery. Yes, who discovered this property first? It was discovered by Camerlingons in the year 1911. Okay, and this is 2023. Means 112 years ago, this property was discovered by Camerlingons. For which material? For mercury. He found this property in mercury below a critical temperature, and that critical temperature was near to the absolute zero temperature, means 0 Kelvin. Okay, that temperature below which mercury could show or exhibit the property of superconductivity, that temperature was near the absolute zero temperature, right? So that is all about the discovery. Next comes critical temperature. I have already discussed about critical temperature, that this is the temperature below which certain properties can exhibit the property of superconductivity. That temperature is called critical temperature. Okay. And next comes Misner effect. Now, point number 4 is Misner effect. Misner effect means it is an effect when certain materials exhibit the property of superconductivity, in that case, those materials expel the magnetic flux, okay, from its interior. From the interior of the materials, which materials? I am talking about superconducting materials. Okay, so below that critical temperature, superconducting materials expel the magnetic flux from its interior, and that effect is called Misner effect, right? That effect is known as Misner effect. Next come types. Yes, there are two types of superconducting materials. Two types. First is type 1 and next is type 2. So in case of type 1 superconducting materials, it is able, means those superconducting materials which belong to the category of type 1, those materials are able to expel all the magnetic flux from its interior below the critical temperature, right? But for type 2 category superconducting materials, they are not able, means those materials are not able to completely expel all the magnetic flux from its interior. That category belongs to type 2, right? So there are two types of superconducting materials, type 1 and type 2. So which one is better? Type 1 is better than type 2. Next comes point number 6, applications. Yes, there are enormous applications of this technology. Yes, it is of course a technology. Okay. So applications you will find in the field of medical science. You have heard the name of MRI. It is one kind of diagnosis technique, MRI, magnetic resonance imaging technology, okay, MRI. So in case of MRI, superconducting magnets are required, and superconducting magnets are formed using this technology, that is the property superconductivity. Okay, so superconducting magnets are required for MRI. So that is the application of superconductivity. Next comes energy. We know that what we know? We know that whenever current flows through electrical wires during power transmission from one point to another or from one location to another, power cables are required, and due to the presence of resistance, there is some energy loss. Okay, so to minimize those energy losses, if you use superconducting materials to manufacture the power cables, then in those cases energy loss will be minimal, right? So in certain cases power cables are manufactured using superconducting materials. So purpose is what? Purpose is only to minimize the energy loss. Okay, so that is here in the field of energy transport. Okay, in the field of energy transport, superconductivity, this property of materials are used in certain cases. Okay, not globally. Transportation. You have heard the name of maglev trains, those high-speed trains. Okay, maglev trains. For the purpose of levitation and propulsion, superconducting magnets are required. Yes, for the purpose of levitation and propulsion, superconducting magnets are required, and those things can be achieved, means those requirements can be achieved by using superconducting magnets. So in the field of transportation also, superconductivity is highly required. Okay. And next comes challenges and limitations. Of course, there is challenges. Why challenges are there? Because you know that superconductivity, this property can be achieved only in very, very low temperature, and that is really challenging. Okay. those temperatures are near the absolute zero temperature, 0 Kelvin. Okay, so that is really challenge. And limitations is what? Limitations means here all the materials do not show this property, means superconductivity. So that is the limitation. And challenges, I have already told you that challenges means you maintaining that low temperature. Okay, that is really a challenging job. And last point is current research and future prospects. So you know that it is in so much demand, this property. So research must be going on in this field. Okay, yes, physicists are researching, are making the research in this field of superconductivity to improve certain things. What are the desired things? Desired things is, say at present this much of temperature is required to achieve the property of superconductivity of a given material. But scientists are targeting to achieve the same property of superconductivity well above the present day temperature. Okay, so if this becomes possible, then maintaining that low temperature is so much challenging. So we will overcome that challenge this way. Okay, if we become able to achieve the property of superconductivity well above the temperature, which temperature? Present day temperatures. Okay, so researchers are required. Many physicists across the globe are making the research, are conducting their research in this field. Last comes future prospects. Yes, future prospects are enormous. Many things can be achieved if scientists become very much aware of this property, that is the superconducting materials. If scientists become able to know each and everything about superconducting materials, and if the scientists become able to show those properties for all the materials, so these are the field of research. Okay, so if those things are achieved by the scientists, many things can be devised by using this property, that is superconductivity. Okay, so many things are there. Okay, so this is the end of this lecture. And if you find my videos useful to you, if you like my videos, so please share and subscribe. Okay, thank you for watching this video.